Right, here we are going to look at VXLAN, that's Virtual Extensible Local Area Network. Not to be confused with VLANs, operating at slightly different levels. We've got VLANs operating at layer 2, where VXLAN is tunneling using UDP. So we get the addition of a UDP, IP, and then what's over at layer 2, which is probably Ethernet, on top of the frame structure that you're tunneling through VXLAN. Both are tunneling techniques. VLANs uses tunneling at layer 2, so it doesn't use as much overhead as VXLAN. It provides 4 bytes to define a tag, and within the tag will be 12 bits which identify the VLAN ID. 12 bits gives us a range from 0 to 4096 possible VLANs now going through this one single connection. VXLAN, on the other hand, is 24 bits, so it can support 16 million separate connections going through the same tunnel. So that directly looks like there's a major benefit there. You could achieve the same thing by having 2 VLAN tags, so stacking tags. 4096 times 4096 is 16 million. So for the same sort of order of overhead, you can achieve the same thing. VXLAN is routable though, so you can route to somewhere within the same data center or in different data centers to get to that other tunnel endpoint. Whereas VLANs requires MAC forwarding and the rest of it, and MAC tables to be maintained all the way through if you wanted to extend this out using a sort of MEF style metro and carrier Ethernets. They both support COS or QoS, as the opportunity to support the QoS bits, which is what we expected. They have RFCs associated with them, or as a draft RFC in the case of the last of the tunneling techniques that's mentioned there, the stateless transport tunneling. But VXLAN and NVGRE, which you might come across, both now have RFCs associated with them. We're going to concentrate on VXLAN, and we can see there's a bit of Wireshark to the bottom left, which tells us that if you look at the bottom here, I've got a ping going through, probably as likely ICMP message, which is carried inside IP, which is carried inside Ethernet, and then it's tunneled VXLAN style through UDP, port number 4789, and then IP, and then under Ethernet. So what we've got here is the outer IP, which is this one down here at the bottom of the stack, is the one that's being used to carry the traffic backwards and forwards. So we've got the IP addresses 1215 and 1220, which correspond to the 2 servers and the tunnel endpoints. There's the UDP port number that's being used as the destination. So we've opened that up, we've looked at the bits and bytes, and we can then associate with the sort of output you would see in the RFC, the IBIT, which tells us that the VXLAN network identifier is here, the VNID, that's the 24 bits, and then we can see that there's the QoS bits, and it's sort of over here somewhere in the actual trace. Looking at the reds, they would have a VNID of 100, and the blues a VNID of 200. Of course, when you look at that in hexadecimal form, you'll find that that's going to be a value of 64. 6 times 16 plus 4, that's right, 100. So sometimes it displays as VNID 100, sometimes it displays in hexadecimal, and that's what you'll just have to pick out of your traces. So what I'm going to build is I'm going to build an environment at one end associated with server 1, which is a Mininet environment, which will generate an OVS switch, which we'll call switch 1, and 2 VMs, one of which will be associated with red and the other with blue. They'll both build with the same IP addresses, and they'll actually build with the same MAC addresses, because I'll force that, as you'll see later. Over on the right, we've got a similar environment, which is actually going to build switch number 2, which will tell it to do that. 2 VMs again, and the first of those VMs will be associated with red, the second will be associated with blue, and again they'll have matching IP addresses, and in fact they'll have matching MAC addresses for this end. So we've got 10.0.0.1 on the left and 10.0.0.2 on the right. They're going to be tunneled through VXLAN to the tunnel endpoints, which you can see using a different LAN. That's representing an external LAN, could be a WAN, of course with appropriate addressing. So the VNID's 100 for red and VNID 200 for blue. So, references to, you could have a connection between, say, an iSCSI initiator and a sound store, and that could be in the same data center or somewhere else, as long as they're using IP connectivity to get to them, and VXLAN for their tunneling. So, the things we're going to do is I'm going to build the environment. I'm going to build the Mininet environments using some Python scripts. So VX example 1 on the left and number 2 on the right. And then what I'm going to do is I'm going to modify their open flow flow tables using flows 1 on the left and flows 2 on the right. And that will then sort of give us that environment. It's not finished yet, because the next thing we'll need to do is we'll need to build the VTEP tunnel endpoints and steer them in the right direction. But the flows will direct traffic down those tunnels, because that's what's included in the flow sort of spec, if you like. Looking at VX example 1 on the left and 2 on the right, you can see as we come down, we're not adding a controller, so it's controllerless. We're building this ourselves. We've got red 1, which will be known as red 1 with an IP address and MAC address. Blue 1, which will be known as blue 1, which will have an IP address and a MAC address, both the same, but we're going to keep those isolated through their appropriate flows. We can see down here we're going to add switch number 1, whereas we add switch number 2 on the right. We're going to add links between red 1 and blue 1 and switch 1. And we're going to do the same thing. So as we've added them, as you can see in the same order, they'll get the first connection and the second connection. We've also added here on the right hand side some printouts where as that starts up, it'll tell us the IP addresses and MAC addresses associated with red 2 and blue 2. So red's on red 1 and red 2 are separated, blue 1 and blue 2 are separated. They're on different servers, and we'll interconnect them using VXLAN. So adding the flows, so we're modifying the flow tables in the OVS switches. I'm going to do that by importing a flows text file. And you can see the sort of makeup of this. It's actually going to modify table 0 and table 1 in both cases. Table 0 first is looking at the incoming ports locally, input 1 and 2. Remember, as they're added, red 1 will take port 1. And blue 1 will take port 2. Over on the right hand side, we'll see that red 2 takes port 1 and blue 2 takes port 2. That's just purely because the order they were built. So anything incoming on port 1, we'll set its tunnel ID to 100, and on port 2 to 200, and exactly the same on the other end. So that's associating port 1 with red and port 2 with blue, and giving it a number. So the next thing we do is we say resubmit that to table 1. So we bring it into table 1, and on table 1 what we find is we've got entries marked up looking for tunnel 100 or 200, so red, blue, red, blue, red, blue, red, blue. These at the bottom 4 are to do with ARP, and the top 4 are to do with data link destinations that match. If the data link destination matches 0, 1, then on the left hand side that's local, so take it out of port 1 or port 2 correspondingly, red or blue. But if the destination MAC address ends in 2, then that's the values that have been set for the devices on the right hand side over on server 2. So they need to go out and use the VXLAN. We're going to send them out of flow 10, and we're going to associate flow 10 with a VXLAN tunnel later on. And we'll do exactly the same on the right hand side. So flows 2 is sort of coming back the other way. And again, if the MAC address is local, so the MAC addresses would end with a 2 this time, then output ports 1 and 2. They're the local ports. Or alternatively, go out of port 10, flow 10, and that will take you through to the VXLAN. And the same is true of the IP addresses. If the IP addresses are local, so end in a 1 on the left hand side, go out of the ports 1 and 2. If they end in a 2 on the right hand side, go out of ports 1 and 2. However, if they end with the address on the other side, then they need to go via the flow, and the flow value is a 10. Everything else, drop. That's what should happen. Okay, assuming we've put all of the commands in the right place. And then the sort of next thing we'll do is configure the VLAN, VXLAN tunnel endpoint, the VTEP. And we can see this is here, so the sense of direction I put on here as well. So the first command is executed on server 1, and the second command is executed on server number 2. And you'll notice we've asked for the open flow port. We've requested a value of 10, otherwise it sets it dynamically and then help. So that's what we need to do to get things up and running. So that's exactly what we're going to do, and we're going to do that, of course, on the VMs, and then we'll come back and have a look at testing those. So let's get our machines up, and we'll put in the very, very, very secure password in both cases. Now I've got Wireshark running away here, looking at UDP port number 4789. Yeah, I'll restart that just as it is hackling away. Good, just minimize that for the time being. I'm in the Mininet examples folder, and I'm looking here to make sure that I've got the Python script and the flows file, the text file that's required here, and the same is true over here. I've just done a straight copy, as you can see. So I've got the number 2s for the other side. So the first thing to do is, under an elevated Python command, is put in the first of the VX examples. Remember, just use tab as you go along. It helps. Bang, that's gone in. Good. And let's do the same at the other end. So again, we're doing Python. And just make sure that that's in. And number 2. Jobs are good. Okay. So you can see the extra printout that you get as a result of the other lines that were added there. Goodo. Now, just going back to the left-hand side, what we need to do here is we need to add those flows in. So we're going to bring the flows in. We're going to break out a shell. There's a number of commands you can run at shell if you can remember them. So we're breaking out the shell and we're running add flows S1 because it's the left-hand side. Flows 1 text because it's the left-hand side, it's server 1. Make sure we're all good and dandy. Should be. Good. If you do get an error though, it's probably because you've got an erroneous character that's appeared. It should tell you which line it's appeared in, or an unwanted space. So go looking for those. Sometimes it's best to open them up in Notepad+, and you can see all the oddball characters. Switch to. Shouldn't talk whilst typing, it doesn't help. There we go, and that's in. Good. But does that mean that I can ping? So can red1, you have to tell it who, ping, you can actually open up, you can open up an X term for this. So you could do red1 as an X term and put ampersand at the end, and then it will actually fire that up as an X terminal, and then you can run all your normal commands in there. But we're just going to do this from the command line. So 10.0.0.1 is of course itself, and 10.0.0.2 is not available because the tunnel's not up. So let's go back and have a look at that, what we need to do next. Now the next thing that we need to do of course is set up the tunnel, and then we can consider actually coming in and testing that. So we'll do that in what they call a jiffy. Okay, so that's the commands, and you see it's quite a long command that we need to put in. So we'll take care over putting those commands into the 2 tunnel endpoints. And remember, it's addressing the other end. So we need to break out the shell again to do this. It's an ovs-vsctl, virtual switch control, vsctl command, as we're adding a port. We're adding it first of all to switch 1, and it's VTEP. Excuse that typo immediately. And we need to set the interface type so that it's VTEP. So type is in fact VXLAN. What we're setting at the option here, and get this right, there's no space there. So option : remote _ IP equals, now it's the other end of the connection, so it's 192.168.1.220, and the second option that we're going to bring up is this for the flow, and there's a space there, so it's OF port, and it's a request, and we're going to make that value 10. Yes, notice the double dash there. There's a space and another space. Okay, otherwise that looks good. And on the other end over here, we need to do the reverse. So again, as we've just done, it's a shell command. It's a virtual switch control command. It's an add port. That's the easy bit. It's switch 2 this time. It's VTEP, and it's effectively we need to set its type. So VTEP and then type equals VXLAN as before. So option, just make sure we get this right, option colon remote underscore IP. So this is the other end of the tunnel, is 192.168.1.215. That's good. And then option, and this time it's a key. So it's the flow ID. This open flow reference that we need. Port request, and again 10. Could have put a different value in, but then and you can play with that at your leisure. That looks good, right? So all being well, we can think about what else we might want to do with this in the shape of essentially testing to make sure that we can get through. So we've set the tunnels. So what we should think about is, can we ping through to the far end, and then we can sort of think about taking things down and seeing if we can ping back the other way. And let's give that a go. Okay, so you'll notice this here is red1 IP link set div red1. If you remember right at the start, we issued a couple of commands to see the sort of setup that we had, and one of those told us about the ports and the connectivity, and that's Ethernet 0 on red 1, which would be the first port on red 1. So if we take that down, then we won't be able to ping it from the far end, is the idea. So let's give that a go, and we'll see what we can do. So if you go back up here, you can see the sorts of things. In fact, let's do that. Let's do net nodes and dump, the sort of three sort of commands that you would normally do. So you can see the output of net. So what that's showing us is on red 1, red 1's Ethernet 0 is connected to switch 1. And you can see similar information down below including addresses. So if we do the same at the other end, if we do the net command, because that revealed pretty much that, we can see again the same true here. Red 2's Ethernet is connected to switch 2's Ethernet 1. Right, good. So all being well, let's just check that. Can we ping the other device? Yes, we can. Okay. So can the other device, red 2, ping 10.0.0.1? Yes, it can. Okay, so this is where we take that interface down. So on red 1, let's take its link and set that red 1 Ethernet 0, if you remember, down. Okay, let's repeat the ping. Not working. Okay, but if we go, instead of doing red 2, let's do blue 2. That's still working. Yeah, and over here we should find blue 1 is able to ping 10.0.0.2. That's not pinging red 2. In fact, we can prove that by going over here and saying to red 2, let's set your IP link and set the device there. So this is red 2 Ethernet 0 down. Okay, and let's just repeat the blue ping, and it's still working. Okay, so if we were to repeat that with red, remember, red's in all sorts of trouble. Okay, so what we need to do, of course, is we need to bring that, instead of down, let's take it back up, and then try the ping. Remember, it said network unreachable before. It's trying. Okay, it's trying. So let's bring the other side up. So we took it down before. Let's bring that back up, and then watch the pings come back into shape. Good. Okay. All right. So we can see then. What can we see? Let's have a look and see what we can see. Let's see. Oh, we need to start that off. And he doesn't want to play ball there, so we might have to start him all over again. The fun and frivolities of Wireshark. That's quick without saving. Let's just pull that back up again. So I'll bring this one into play and see what happens. Fire in the hole. Okay, we'll just pull up any interface for quickness. And we'll do that. So we'll put the filter on as well, UDP port, just to make sure that we've got the right value in there. So nothing happening there. That's fine. Just minimize that beastie out of the way. Okay, let's do a ping. So we'll do a red to ping 10.0.0.1, and there we go. We've got some activity coming through straight away on VXLAN. So we can stop that, of course. And as we can see that we've got 10.0.0.2 making the request and the reply coming back. Notice it's the 10s that are involved, but if we have a look, we can actually see that it's actually being carried by 220 back to 215 using that port number. And we should see the VNID is indeed 64, which is 100. 64 in hexadecimal, of course, as revealed by that. We're not setting any quals on anything. And then we can see the IP addresses of the tunneled packets going through, carrying the ICMP message, which only thinks it's carrying that. And we can see that going back in the reply. So we can see the ICMP message, and we can see the data in there. And that really constitutes the original packet. So that's good. All is dandy. It's all working, and Wireshark is proving that fact, as we can see the packets going through there under port number 4789. Okay, good. So let's just drop that one down out of the way, and that is really it for this particular session. So hopefully that's got you rolling as far as VXLAN. Of course, you could go and modify the flows tables, because there's certain activities that have not been restricted necessarily, but they were certainly sufficient for this demonstration. And thank you for watching.